You go 6 horizontally, left and right. There's your vertices. Go 4 above and below, vertices. Draw your ellipse. That'll do. I'm going to write the standard form equation. That usually isn't a problem, but the center is the origin, so you just have x squared and y squared. And this goes with the x, so it still goes with the x here. It just gets squared. Of course, we call this one a because it's bigger, and this one b because it's smaller, but placement, like I said, if a is with the x here, then it's going to be with the x here when you square it. Now, as far as starting point direction, 1, 2, 3, 4, 5, 6. Okay, point's right, it's just a little off. But all you need to do for starting point is plug in 0. And actually, they use theta here instead of t, so I guess I'll use that. Usually we use t. And if you plug in 0, cosine of 0 is 1, times 6 is 6. Sine of 0 is 0, times 4 is 0. So 6 times 0 is your starting point. And then for direction, once again, we mean as you travel, well, as t increases, or state increases, which way do you travel? So pick a number bigger than 0. For trig functions, I'll do pi over 2. But it's your choice, or if you want to. And then cosine of, so you get 0 there. Sine is 1, 4 is 4 for that coordinate. So you're up here next. And really, you don't have to label that point, you just need to indicate the direction. You're going counterclockwise. Listen, the book, frankly, it doesn't do much with this. All it does is shows you where you can have it like that, like normal with cosine first and sine, and like 22 where it swaps them around. The reality is, like I told you, you can coordinates, the coefficients I mean, to be positive or negative. So you get a lot of different possibilities. So this always works though. Just plug in 0, then plug in something bigger than 0, figure out the coordinates, and that'll tell you. I will do one more. This one, first we'll draw it. Go 8 left and right, above and below. So your distance are 8 and 1. Draw your ellipse. Long, skinny ellipse. I'll leave the equation. Now, to get starting point direction, do the same thing. Plug in 0 first, okay? And Zoe, what's sine of 0? Zoe, sine of 0. Good. So you get x is 0, and then cosine of 0 is 1, so you get 0, 1, which is actually the top this time. And if you plug in 2, now sine is 1, and so you get 1 times 8, 8, and then cosine is 0, which means now this point is next, which means it's going clockwise this time. So if you want, you can label this other point here, just show the direction. And really, that's it. Then these, they're all going to be like the first one or that one. But this is normal. If you have positives for both, cosine here, then sine here, then it's just normal, just like you're on the circle, actually. Start at the right, go counterclockwise. And if you make them swap like that with sine here and cosine here, well, that way. It's not until you start changing the sign that you get other variations. All right? All right, set that aside. Okay, I want hyperbolas, obviously. Hold on. Just want to mention this. You know, it's one of the conic sections because it cuts the cone differently from the rest. Okay, called conic section because it cuts cone, but it cuts differently, and it cuts both naps of the cone. Now look at this. We call this one a horizontal hyperbola. It's like two parabolas that open left and right, except for they're not parabolas. For instance, it has asymptotes. Parabolas don't have asymptotes. So now watch this. Notice. Hold on. There. So look, what I'm bumping up is the horizontal distance to the vertices. I make that smaller. The first thing you should notice that should really stand out is this horizontal distance is not bigger. So look at this. A is smaller than B. I can make A bigger than, or equal to B. I can make A bigger. It's still a horizontal ellipse. I mean, yeah, hyperbola that whole time. And so that relationship that held for ellipses doesn't hold here. Tell me this is a horizontal hyperbola. How would you know by looking at this equation that it's a horizontal hyperbola, do you think? And it's not as much about order as sign. The fact that it has a negative sign right there is what tells you it's a hyperbola, okay? The fact that x is in the positive fraction is why it's horizontal. In other words, if I made this negative and made that positive, you'd be seeing a vertical hyperbola instead. So it's all about sign here with hyperbolas. Now, one more thing I want you to see is, the distances mean the same thing. A is the distance to a vertex, just like before. B is the distance to a vertex. C is the distance to a focus. Now, if you look at this, so that's A, it's distance to the vertex. B is this distance here, but you notice that this covertex, they don't even have it. It's not a point on the graph. The reason it matters, though, is because these asymptotes have a slope that is, like this one, it'd be B over A. You go up B over A, that'd be the slope of your asymptotes. So I'm saying that's where B comes in. It gives you the asymptotes. Now you have this in your paper, the definition of hyperbola. It looks just like the definition of my ellipse, except for the definition of ellipse would replace difference with sum. So on an ellipse, the sum of the distances to the foci was a constant. For hyperbola, the difference is a constant. And I want to add this on. That constant is always 2a. Write that down, Michael. So if you found, you're on the hyperbola, you found the distance to the other focus, found the distance to this closer focus, subtract the 2, you'll get 2a every time. All right? Now look at this. You have this in your paper. Once again, if it's a vertical hyperbola, the vertices and foci are above the center. If it's a horizontal hyperbola, they're left and right. And actually, let's just talk about this real quick. Like I already mentioned, A, B, and C, they mean the same thing as before. So to get the foci, for instance, you go C. But on a hyperbola, C will be bigger than A, right? And so look at this. Your formula that relates A, B, and C is different. C is now the biggest. It looks like normal Pythagorean theorem, even though the letters mean something different, but it looks the same. So that's one huge difference. The other thing that's not labeled is, like, look right here. This is a horizontal hyperbola. This axis that connects vertex to vertex is your transverse axis. Go ahead and label it. Like I said, on a horizontal hyperbola, you have the horizontal transverse axis going from vertex to vertex. If it was a vertical hyperbola, well, then you have the vertical transverse axis going from vertex to vertex. And like I said before, they don't call it like major and minor axis. Or I guess I didn't say that. But they don't call it major and minor because, like I said before, the transverse axis isn't always the biggest. It could be smaller, it could be equal. You don't have that kind of relationship. So this one's called transverse. The other one, they call the conjugate axis. So like I said, if you go from vertex to vertex, that's the transverse axis. And by the way, that is 2a in length. Well, I mean, your picture is a little different from mine, but still, on the horizontal hyperbola, that should be horizontal, and the transverse axis is the horizontal axis. The conjugate is the vertical on this picture. I guess I could have done it on your picture. I'm saying that would be the transverse axis. And I'll just label that, frankly, since that would suffice. The other one's the conjugate. Like I said, the transverse goes from vertex to vertex, which is why it's 2a in length, and the conjugate goes the other way. Like I said, here, if it's a horizontal hyperbola, then the transverse is horizontal. Vertical hyperbola, the transverse is vertical. Okay? All right. One more thing I want to show you about these equations. I'm going to write them like this. The problem is, if I ask for the center, a lot of people will mess up because of the order here. and they'll say, oh, like K, comma 8, backwards. So some teachers, maybe even some books, will write it like this, where X always comes first. I'm not going to write it that way. You'll never see it that way from me. It is the same. And this is what I want you to appreciate, is that, like, this is vertical because Y is in the positive fraction, not because it comes first. Because you could write it like this, and it'd still be the same vertical hyperbola. So since Y is in the positive fraction, that's how you know it's vertical hyperbola. Someone chose to put this first. It would look ugly because we don't like having a negative sign sticking out there. But you could. All right? All right. These rules, remember this. You know, if you're missing, if you had just x squared, you know it's a parabola. If these coefficients the same, that's in the circle. And then the other rules, if they're the same sign, but not the same as ellipse, if they're opposite sign, it's hyperbola. Now, before we do this, I meant to change these, and then, well, I did, and then it didn't save. Make some changes here. The last example, make it a minus. And we're just going to get rid of both these terms in this one. That'll be the easiest fix. Now let's go through. What's the first one? Shape. Yeah. And once again, remember that these rules only apply if it's in general form. So on the first one, you have to move this over. It would actually become a positive, right? So yes, it is an ellipse. The next one, because they're exactly the same coefficient. Next one, because it doesn't have both x squared and y squared. And the last one, they're not the same. They're opposites, right? So hyperbola. And like I said, you know, A and B could be the same. One could be bigger. One could be smaller. It doesn't matter. If they're opposite sign, it's hyperbola. Okay. All right. Let's get this done. Let's get going. This one, the same as the origin, obviously. Listen, what kind of a hyperbola is this? Vertical or horizontal? Because here, you know it's a horizontal hyperbola. Okay? And that means this is a squared. A squared is always the denominator in the positive fraction. So A is 7, and it's horizontal. Then B is 9, and it's vertical. And C, by the way, we'll have to compute, but it's going to be the same direction as A, because the vertices and foci are always on the same axis. So it's also horizontal. So we can go and draw the thing right now. Let's go and draw it, and then we'll figure out some other things about it. So you go, well, the 7th horizontal, so go left and right horizontal. Go 9 above and below. Listen, you've got to get the asymptotes drawn accurately. To do that, you have two options. You can draw a box, and I'll show you in the next example how to use the box to get the asymptotes. Here, it's really easy, though. In fact, here, we're going to write the equations for the asymptotes first. The asymptotes will be two lines that go through the center, which is the origin in this case. So it's really simple equations here. The slope uses A and B. Well, in this case, would it be B over A or A over B? Slope is always vertical over horizontal, isn't it? So in this problem, it's 9 over 7, not 7 over 9, because the 7 is horizontal, so the 9 is vertical. So I'm saying the slope of the asymptotes will be 9 over 7. And actually, put a plus and minus, because you already have two asymptotes. One goes up, one goes down. So, and I already did that. If you go up 9 and over 7, you get a point on your asymptote. Go down 9, right 7, you get a point on the other asymptote. And just go every direction. And just draw your asymptotes through those points. Come down, go to that point, go to the center. And then draw the other one. Let me fix this part. And let me stress again, your asymptotes have to be accurate. When you're drawing a graph that has asymptotes, it's supposed to approach the asymptotes. And if your asymptote's wrong, then your whole graph's going to be off. And so, plot points, do it accurately. If it's just a rough sketch, I'm just going to mark it wrong. Now, listen, one thing you understand is, like everything we've done, I would have done the exact same thing Watch. Don't write this down. But if I gave you this equation for a vertical hyperbola that has everything exactly like I have it on the screen. The 7 would be a horizontal distance, 9 would be vertical distance. It'd all be the same. You have the same asymptotes. The difference is here, you draw the hyperbola above and below because it's a vertical hyperbola. Ours is a horizontal hyperbola. So just be cautious. Make sure you're very clear which way you should draw it. In fact, I would recommend, like when A was 7, A takes you to the vertices, label them as vertices to remind you where to draw it. It's easy though. All you do is from the vertex, approach the asymptote, and just kind of curve towards it, both directions. And just do that on both sides, and you're done. Kind of anticlimactic because you've done all this work to get the asymptotes right and everything, and then you just draw the hyperbola. By the way, let me just remind you basically the rules for when it comes to drawing asymptotic behavior. So, let's say you have an asymptote. It shouldn't cross an asymptote like that. That shouldn't happen. It should also not curve away. It should just be approaching. If you do it like that, then no, you don't understand. What's really bad, this is what I get from some people. Always someone does this. They draw their asymptotes, they put a little U here, a little U here, and it's like, no, that's sad. You have no clue. Okay? So, and I'm serious, if you draw it, and like you get so, it looks like you touch, I don't care, because frankly, it's going to get so close you can't even tell the difference, right? So just do your best, make it approach. If it looks like it touches, just leave it. It's okay. Just try not to cross over horribly. Definitely don't pull away. And it's good. All right, we're going to do 2 more things. I want the foci. Okay? Now for that, we need to find C. And remember what I said, the foci are the farthest away. So the Pythagorean theorem looks like this, with C being the biggest. So it's 49 and 81, which adds up to 130. So C is the square root of 130. For plotting purposes, that's good enough. That's what, 11 point something, 12 point something, what? It's more than square root of 121, less than square root of 144, so yeah, 11 point something. So go out, and actually it's going to be off the grid anyway, so just put it out here. Estimate a little more than 11 that way, a little more than 11 this way. There's your foci. And I'll reiterate, they're going to be in the same axis as the vertices. What do you call this axis that goes from vertex to vertex? What's the name? Transverse axis, okay? So they're always on the transverse axis with the vertices. As far as writing the coordinates, you need this, the radical form, which we need to simplify. So it's kind of big, so I'm going to break it down. Half of 130 is 65. You can't divide that by 2 or 3, so I'll divide by 5. What do you get? Good. Which means you can't actually simplify it radical. So we just leave it, actually. But which way do we go from the center to get to the foci? Left and right or above and below? Left and right. I'm saying, what we just found is the distance to the foci. I'm trying to write the coordinates, but I'm asking, which way did we go? We went left and right. So you should go 0 plus square root of 130 and 0 minus, which is just plus or minus square root of 130. Put the same y value because, we went left and right, not up and down. I'm going to do one more thing. The eccentricity is always C over A by definition. In this case, it's a hyperbola. You should get something bigger than 1. So C is bigger. C was square root of 130. So it's square root of 130 over 7. And we're really not going to delve into that much. That is more than 1 though, because that was 11 point something. And if we had time, we could get those as decimals and kind of draw a bunch of them and see how changes in eccentricity kind of affects the graph. But just be able to compute it. That'll be good enough for now. All right, questions about that one? Then let's move on. Now, that one was nice because of the center of the origin. In general, your equations for asymptotes look like this. What I want you to realize is this is just point slope form. You've done point slope form, I know, in Algebra 2. Pretty sure in Algebra 1 as well. So look, point slope form looks like this. Here, though, you have two lines, and the point they cross at will always be the center, not the origin necessarily, but the center of the hyperbola. That's what I appreciate. What's nice about this, because look, I guess in this way, a lot of teachers don't like point slope form just because you don't get a unique equation. And the reality is the x1, y1 that's in there could be any point in the line. So if you knew 5 different points in the line, you could write 5 different equations. They'll all be correct. So that's the bad thing about it. The good thing is what you see here is two lines that have one positive, one, both to the same point, and just have, like I said, one positive, one negative slope. And it's nice and easy and elegant. If you tried to write slope-intercept equations for these lines, it would be a pain. They're not going to have nice y-intercepts. We don't want that. So that's why we use this form. All right, here, let's do this one. Where's the center? Miriam, where's the center? I'm hidden. Well, that's okay. First period, they made the same mistake. Second period, they noticed the order. So be careful. That's why I said. That's why some people, they always put the x first, because it's easy to mess up, right? Okay. Just be really cautious. But what kind of hyperbola is this? Horizontal or vertical? Vertical, because the y is in the positive equation, so you know you're dealing with a vertical hyperbola. So that means, and this is always a squared, and so a is 2, and it's vertical. And b is 3, and it'll be horizontal. Now, let's go and draw the hyperbola first. So 2, negative 4. Now there's my center. Am I going to go up 2 and right 3, or right up 3 and right 2? Get to, what's the slope? Is it 2/3 or 3/2? In this case, it's a over b, because a is vertical. Slope is always vertical over horizontal, right? So that's what I want you to appreciate. On this one, it was b over a, because b was vertical. It was 9/7 for the slope of the asymptote. Well, now it's a over b. It's 2/3, because a is vertical. So, and I really expect you on this, something like this, plot these points. Go up 2, right 3, up 2, right 3, and just plot all these points. Do a good job on getting these asymptotes accurate. That'll do. Now, I drew the asymptotes first. If you prefer to watch this, A was 2, is vertical, so you can go, from the center, go up 2 and down 2, plot those points. B was 3, go left and right. And so you can plot those first, and then just get these points and form a little box like that. And you really should see that box, but some people actually draw the box. I don't take the time to draw the box. The point is, you need these points on your asymptotes. Question? Well, again, I'm telling you, use A and B. And, slope is vertical over horizontal. So I did 2 over 3. So I'm saying I went up 2, right 3, up 2, right 3. All I did was, what are A and B, though? A is the distance to the vertex. So this is actually a vertex here. And so, it's just always going to line up. The vertex will always line up with the first point on the line. And this point, the covertex is also line up with that first point. Now, and draw the hyperbola, because vertical, draw it up here. Just once again, start at the vertex and try to approach the hyperbola. Let's go get the foci on there. Once again, first we do the Pythagorean theorem. It's just, what, square root of 13? Which is less than 4, 3 point something. So from the center, you go up 3 point something, which puts one focus right about there. And then from the center, you go down 3 point something, puts the other focus thereabouts. Now, if I write the coordinates for those foci, Michael, what would the coordinate in exact form for this focus above the center be? I want the coordinates for this focus. It would be 2 comma what? You're going from the center this far, so you increase the y coordinate in the center by that much. And really, for the other one, you just put a plus minus, and you have both. Remember we said square root of 13 is 3 point something, right? So look, if I do negative 4 minus 3 point something, I get negative 7 point something, which is where this is. You count it out, that's 7 point something below the origin. If I do negative 4 plus 3 point something, I get like negative 0 point something, which is the actual, the approximate y coordinate for that other focus. But this is how you write it exactly. And we still need asymptotes. So here, and frankly, it looks a whole lot like, if I go back, oh, there they are. If I go back and show you this, it looks just like the equation for the hyperbola. It has y minus k, it has x minus h, except for y minus k always goes over here, and nothing squared. So just do, it's y plus 4, you do y minus negative 4. Over here it's going to have x minus 2, so you do x minus h there. And you just put the slope here, and the slope was 2 over 3. At this point you're half right, because there's 2 lines, one with a positive slope, one with a negative slope. So don't forget the plus minus, because I only give you half credit. Which is sad, because you did all the work. Yeah, they don't go through the origin in this case, they go through that center. Let's do the eccentricity one more time. C was square root of 13, so it's square root of 13 over 2. Which once again is more than 1, even though it's a hyperbola. All right. Frankly, I think we'll just draw one more. Any questions about that one? Yeah, let's do this one. Where is the center? Don't blurt it out, just think. Hayden, you get a chance to figure it out? Is that right? It's not a bad idea to just plot the points first. 1, 1 is here. 1, negative 5 is down here. And sure enough, halfway between them is that. You should be able to do it with, mathematically first, though. So here, watch. If you average those y values, if you do negative 5 plus 1, divide by 2, that's negative 4 over 2 is negative 2. But then, no matter what mathematically, in other words, this is supposed to be in the middle. 2 from negative 5, 3 away. And it's 3 away from that, so you're good. Or you could just do it using distance. In other words, how far apart are these foci? 6 away. So the middle, the center is 3 in from either side, right? I'm saying there's various ways to figure it out. Double check it, please. If your center is wrong, the whole thing's going to be wrong. By the way, we need to figure out these distances. These foci, we just figured, are 3 away from the center. So that means which one of these is 3? C. C is the distance, stands for that distance to the focus from the center of the focus, so we know C is 3 now. The transverse axis is from vertex to vertex, so it's 2a in length, so a is 2. By the way, is this a vertical or horizontal hyperbola? These foci they gave us were above and below the center, so you know this is vertical distance, so this is also vertical distance. Yes, it's vertical. All right, we still need B. So do that. So you end up subtracting like that. So 9 minus 4 square root of 5. All right, this thing drawn. So we already, the foci, I'm sorry, we have those already. The vertices will be in the same direction. Now, square root of 2 is 2 point something. Just go out 2 point something from the center, 2 point something, left and right from the center. Here's where I would recommend drawing the box. I'm not going to try to plot a bunch of points with a slope like that. So just watch. At every vertex and co-vertex, just draw either a horizontal or vertical line. So I'm going in it. You want to line up, like here's the vertex. I'm going to go through the vertex. Line it up like that. Make yourself a little. And then the vertices of the box will be points on your asymptote. Like I said, if A and B are whole numbers, then I generally don't do this. But when they're radicals, then I think this is helpful. And then just draw your asymptotes. And you can just estimate. Come on. Hold on. I'll draw yours. This thing's not cooperating. Yeah, just get as straight as you have to. It needs to be as accurate as you can. I'm saying with radicals in there, if you just have, basically have 3 points in the line, that's sufficient. And then once again, first of all, the hyperbola goes through the vertices. Don't make it go through the foci. And it's vertical. Make it approach the asymptotes. Let's go and write the equations for those asymptotes. Actually, we need the equation for the whole thing as well. The asymptotes, once again, use the center, will be y plus 2 equals, and over here you'll have x minus 1. Nothing squared, don't do that. The slope, kind of ugly. The slope is 2 over radical 5, or 2 radical 5 over 5, if you simplify that, with a plus minus in front of it. Hold on. Yeah, now the actual equation should start with what? Should it be x minus something squared first, or y minus something squared first? Because it's vertical, yeah, we'll do the y plus 2 squared first, then the x minus 1 squared second. And then a was vertical, so a squared goes with the y. And then b squared is 5, it goes with the x. There we go, there's your equation. Questions? You try this one.